Okay, good morning everybody. Yesterday we stopped while we were looking at this code about PFRAD. Okay, we said that we are going to make a hierarchy of PFRAD classes. It will be very simple actually. It will be
Sorry, can I see it?
It will be just a base class and a derived class. Okay, and it will look like this. Let's try to draw the UML diagram for this class. Where should I? Okay, we talked about this. We talked about that. Yeah. And this the reason why we are looking at this example is because PFRAD has copy constructor, destructor, and the assignment operator defined. And we said that these functions, these special functions actually, they are inherited. Okay. Well, I mean, this is not exactly correct, not inherited. They are inherited, but they don't become your constructors, copy constructors, destructors, and assignment operators. They are available, they are inherited, but you need to, your default copy constructor, destructor, assignment operator, and default constructor is still valid. Okay, so you inherit them, but they don't become your constructor, destructors automatically. So that's why I put them in quotes. Okay, it is not exactly true. Functions not inherited. They are inherited, but they are not inherited the same way. So we are looking at this example because the PFRAD class has these functions defined, and we are going to see what we are going to do for the derived class. So remember our PFRAD class. Let's try the UML diagram. I think we have data. What was it? As usual, our school internet is not good. Let's try my cell phone stuff. Okay, we are back. Do you guys hear me? Do you guys see my screen?
Yes, we can.
Okay. So this PFRAD has this A capacity unused. Okay, let's look at this. There is this A which is a double pointer, and we have this capacity which is an integer. We have used which is another integer. So this is my data section. In my function section I have my PFRAD. I have my, okay, how many constructors do I have? I have 1, 2, 3 constructor including the copy constructor. So I will not write those. I have add element, full, get capacity, etc. So constructors, 3 of them. Add element. Okay, it takes an integer and get used, I guess. It returns an integer and then what? Empty, etc. So I am not going to write the rest. So this is my class PFRAD. Okay. Now I'm going to derive another class from that, and we are going to call that PF array backup. That can take the backups of this array anytime that we like. It will keep my array in some safe place. So whatever I make, whatever I have as modification on my array, they will be taken, they will be modified, but as soon as I say restore, I will get the backup copy. So that's what we are going to do. And so just ignore this data part now, data member part now. So, and I have this constructors again. Constructors, again, 3 of them. And because the base classes constructors are not my constructors anymore, and I have this restore function, and I have this backup function. That's it. That's the whole class. Okay, that's the whole class. What does that mean? It means that it looks like a simple class, but it is actually not. It is actually not a simple class. Why it is not a simple class? Because this can handle all the index operators, get element, get used, and etc. Okay, because this PFRAD backup is actually a PFRAD class. Okay, so this is my UML diagram, and let's try to look at this one. So what are we gonna have now? What do you need to copy to keep a copy of the data that you have? I think we are going to have something like this, right? We are going to have something like this, a pointer that points to a double pointer. As soon as I say backup, I will copy everything that is pointed by this A to this new place, and I know the numbers, and that will be it, I guess. So it will be, let's say, backup. Let me try to write it so that everybody can read it, including myself. So it is backup. It is a double pointer, and B size is an integer. Okay. So that's what I need. Okay, good. That's what I need to store as. That's what I need to store as my data. Okay, so that's my whole design. So let's look at the code now. Where is my PFRAD? I already know. My copy constructor is, which is important. My assignment operator here. My destructor is here. And just kind of a reminder for us, let's look at their definitions. Remember this copy constructor. I get the capacity and use from the other PFA object, and I make a new double array, and I copy the elements of the other array to my position here. Okay, so that's what I do. And then index operator is like that. Assignment operator is say that if the other side is the same as my size, then I don't have to delete anything. I would just copy everything. Otherwise, I would delete my position. I would delete my array A, and I make a new one with a new capacity, and copy the capacity and use and do the rest. That's the assignment. Destructor says that I am going to delete this A. Okay, since this is a array allocation, then I need to use the square brackets. I guess that's it. That's the whole thing. Okay, so let's look at this PFRAD backup. PFRAD backup keeps a double B and use B. Let me change my, so B means backup and use B, so that we are using the same. Okay, use B is the size of that one. Okay, good. Okay, let's look at this PFRAD backup implementation. So as you see, all I need is these two actually. I need these two, and other than that, the rest of them are the rest of them. I add them because I have to. Because what did I say? If I don't make a new copy constructor here, default copy constructor will be used, and default copy constructor does member-wise copy, and member-wise copy I don't like. Why I don't like the member-wise copy? Because it does shallow copy, right? Shallow copy is not good for me because I have this pointer, right? How about this one? I have to add this assignment operator. Why? Because the default assignment operator is again member-wise copy, and it is shallow copying. We don't like it. We need to make a deep copy. And Destructor are there because I have dynamically allocated memory spaces for this class, so I need to deallocate them. That's why I need the Destructor. Okay, so 1, 2, 3, I need them because they are not inherited the same way. Also, we need these stuff, and usually it is a good idea to say this and explicit, because I don't want any integers to be converted to my PFRAD backup, right? We look at this at the when we look at the PFRAD class. Okay, let's look at the implementation. Implementation, this no parameter constructor is very standard. Look at this one. It is interesting, right? It says that to make a PFRAD object, PFRAD backup object, okay, first call the no parameter constructor of the base class, which is PFRAD, okay? So I call it, then my use B, this is, see this use B is my, my name is PFRAD backup, okay? I am responsible for initializing this B pointer, which is a double pointer, and the use B value. So I initialize the use B this way. I initialize my B array this way, okay? And I let the base class constructor initialize whatever belongs to the base class, okay? So in memory, actually, it will look like this. I think I had drawn somewhere. Where did I draw that? I think I had drawn this somewhere. Where is it? Not that one. Yeah, okay. When you say PFRAD backup an object, PFRAD object of size 10, okay? This is what happens. Okay? So inside this PFB object, this part is PFRAD object. This part is the rest of it, okay? This one has use, capacity, and double pointer, and I have one use B and double pointer. I am responsible for initializing these two. For these three, I am calling the base class constructor, okay? So I am treating the base class like a stranger class. I am saying that, okay, I don't know what you are doing in your with your private data. I don't care. All I want you to do is initialize your data. So I call it constructor. That's what I do. Okay. So of course this one is going to point to some place in memory, and this one is going to place some other place in memory. That's what's going to happen, but for now, this is the picture. This is how we write stuff. Okay, so let's look at this. Let's look at this other constructor which takes this capacity value, and again, our use b is going to be 0, and I am going to call the PFRAD constructor to initialize with the capacity, and I get a capacity. See, can I say, question for you. I know I shouldn't do this, but can I say this? Does it compile?
No,
Why not? It's my private data.
it's private data of PFRAD. We are PFRAD back, so we cannot reach it.
Yeah, I heard what he says. Did you hear it? Really? Did you guys hear it? Well, they don't care. They have their own things to do. Our class, what's your name?
Sonar.
Sonar says that, no, you can't do that because capacity is not my, what is my name? My name is PFRAD backup, okay? Capacity is the private data number of PFRAD, not my private data, okay? So that's why I don't have access to base classes, capacity data directly unless what? Unless
It is protected.
what?
Protected.
Say it again.
If it is protected, we can.
Yeah, unless it is protected. Let's see if it is protected. Yeah, it is protected actually. I assumed it was private. Yeah. So PFRAD defines its data in protected section. That's why now I can do this. I can directly access the capacity from this point because all the protected data of my base class becomes my protected data. Okay. All the protected data of the base class becomes my protected data, so I can have direct access to it. But I shouldn't do this. Okay. The way this is the okay. Okay, line 15 is a much better line than line 16. Both of them would compile, okay? Both of them would compile, but line 15 is way to go, okay? That's why some people say that, why do we need protected, okay? Why do we need protected? Because I can live my life happily by using the public interface of the base class. And some other people say that, no, that's not that efficient. We need direct access to this data, and etc., okay? That's what we say here, and we are going to see their point when we try to implement this backup and restore functions. Yes.
Can you use capacity value variable?
Can you?
Capacity value variable. Integer capacity value.
Yeah.
Can you use instead of get capacity?
Capacity value is my parameter. It's a local variable. And local variable dies at this point, line 18.
I mean, for declaring size is double instead of get capacity because.
You mean instead of?
Yes, instead of it.
Sure, yeah, but that's what I'm saying. I mean, this is a local variable. You can do whatever you want with it. And since I am using this capacity value to pass it to the PFRAD, this capacity value has to be the same as the base class's capacity value. That's why they are equal, and if it would be equal to, it would be exactly the same as the using capacity value. That's true. But I think this looks nicer. This looks more readable because base class's capacity is now like my capacity. I am doing that. And if you are concerned about making a function call and being this less efficient, no, it is not actually, okay? Because if you optimize your code using that optimization flags, the compiler will not make any function calls. It will use the value directly. It will be as efficient as using capacity or capacity value. Okay, so that's a good point. Thank you. So let's move on. Let's look at this copy constructor. Okay, copy constructor takes a PFRAD backup constant reference, and as soon as it takes it, it sends it to PFRAD copy constructor. It is interesting code here. Why do I say it is interesting? Tell me why this line is interesting. It is interesting because it is red. Yeah. What else? Why is this line interesting? Line 21.
Because we send PFRAD backup object to PFRAD.
Exactly, right? We are trying to send a PFRAD backup object to a PFRAD, a function that expects a PFRAD object, right? Remember, PFRAD expects an PFRAD object, constant reference PFRAD object, but I am sending a PFRAD backup and it works. And it works. Why? Because there is a relationship between PFRAD and PFRAD backup, right? And compiler knows about the PFRAD. Compiler knows about this is a relationship. That's why it works. It is but I mean, if you think about this PFRAD function, PFRAD copy constructor function. Okay, here it is. I am expecting a PFRAD object, so I got one. This one doesn't know that it is getting a PFRAD backup object, but since that PFRAD backup object has get capacity, get number use defined, okay, it has this capacity value, it has the use stuff and everything, right? So it should work fine. Okay, this is the relationship guarantees that the past PFRAD backup object has everything, like get capacity, it has the .a data member. What else? Yeah, get number used. They are all available, so it is usable. Okay, so that's the beauty of is a relationship. Okay, you just write one generic function. That generic function is going to work for all the classes derived from your base class. You write your code for your base class, okay? You write your code for your base class, and whatever I derive from your base class, your old code will work for my new classes too. They have to. Why? Because all the derived classes has to satisfy this is a relationship. It is guaranteed by the compiler. Okay? Good, so let's go back to that interesting line. Since I told you why it is interesting, it is not as interesting as before. Okay, let me remove that red stuff. So what do I do now? I know that, remember this part? Okay. I know that the copying of this part will be handled by the base class's copy constructor. So I will not think about it. I will ignore that part, because base class's copy constructor handled this part for me. I need to handle this part. Okay, so that's what I am going to do now. Okay, I say that I get the capacity a new B, and all the object use B and it will be copied to me, and then I will copy all the objects. I hate this name, all the objects. This is other. Okay, other, right? Okay, so the other objects use B will be copied to my use B. Since I have enough space, get capacity, and I am copying the other objects B to my B. Not A, I'm not talking about A. A is already copied here, okay? This one handled everything. It copied what? It copied the use value, it copied the capacity value, and using the deep copying, it copied all the elements of A, okay, one by one. Now I am doing it for B, because remember this picture? This picture, okay, A points to some place in memory, B points to some other place in memory, okay? I need the deep copy both of them. The A is handled by the base classes constructor, copy constructor. Now I am doing this. Okay. Good. That's what the copy constructor does. Okay. Good. Any questions so far? Okay. So let's look at the other not inherited functions, which is the destructor. Okay, I say that delete B. Well, so it's interesting. So who is calling my base classes destructor then? You don't have to call the base classes destructor. Like remember when we do the composition, we didn't have to call the base class. We didn't have to call the destructors of my objects or objects through composition. Okay, so destructors are called automatically. So when you do this, base classes destructor will be called automatically. First, this one will be called delete B, the derived classes constructor. After that, it will call the base classes destructor. Okay, so that's the order. Okay, what else? And assignment operator. It is not inherited. It is inherited, but it doesn't become my assignment operator. This is what I do. Okay. Again, I am going to use the base classes assignment operator to use some useful stuff. I get the right side, okay, and I immediately do this calling. Okay, call the base classes assignment operator on the right side. Again, this is an interesting line. Why? Well, I kept saying that I don't inherit the base classes assignment operator, but it's not true. I inherited, it is available, and I can call it. I call that with this right side, which is a PFRAD backup object again, but this one is expecting a PFRAD object, which is okay, because there is an ISA relationship. So by doing this assignment operator here handled the double pointer A, integer used, and integer capacity. The rest of the assignment has to be done by myself. And I'm kind of doing the same thing. If my capacity is not the same as the right side capacity, then I delete my B, not A but B, and I get this new double right side capacity, or get capacity, doesn't matter in this case. Okay. In this case, and I assign it to B. And after that, I assign my use to use B, okay, and I copy the elements one by one from B to B. Good. Note that I always make sure that, okay, the size of the data, the array, and the size of the backup space is exactly the same. It is 10 and 10. It is defined by the capacity, right? It's defined by capacity. Good. Okay, so this is the assignment operator. What was the big three? Copy constructor, assignment operator, and destructor. We looked at them. We looked at the constructor stuff. Let's look at the interesting stuff now. I mean, let's look at why. Let's look at the functions, okay, that make this class backup and restore. Okay, well, they look very simple. Let's look at them. Okay, backup says that, okay, I will back up two things. One is my used value. I mean, I need to keep this used value somewhere. My capacity will not change by making a backup or restoring it, okay? By making a backup or restoring, my capacity will not change, okay? That's one thing. So I am not going to modify backup capacity at all, but my use is going to change, okay? I will get number used to use B. So I am keeping this. So I will, if I show you this thing again, what am I going to do? I will copy this use value to this use B. That's one thing, okay? And then I will do this copying of this array into this array because I am taking the backup, okay? I will copy from this location to this location. How many of them? How many of them? Either capacity of them or use of them. I think the book is using use them, okay, because it is more efficient, okay. So from 0 to use B, BI gets the value of operator index I. So interesting code, right? Operator index I, or I could have said this. I like this one, but just to show you what is possible, I could have said a I. This is possible too. I don't like it, but it is possible. Why? Because A is my protected. I have access to A. Base classes, data member A. This one uses the, line 33 uses the public interface, which is the way to go. Okay, line 34 uses direct access to my protected data. So both of them are compilable, both of them are runnable without any memory leaks and etc. But I prefer line 33. So let me make this like that and make it like this. Okay, good. So this is backup. Restore is something like this. Restore is, oh, interesting. Did you see this? I think last year I played with this code. This one works, kind of weird, but yeah, it works. So did you understand what I did? I say that when I restore it, okay, I empty the array first. What do you remember the implementation of empty array?
It assigned a used value to 0, I think.
Exactly. Yeah. Yeah. Exactly. Assign 0 to use value. Just one line of code. So empty array just empties my array. So what am I gonna do? Well, I kept all of my values. I kept all of my values in this array B. So what am I gonna do? I just push them one by one to the end at the end of the element using add element function. That's what I'm doing here. Okay. I don't think that this code comes from the book. I think I made this. So maybe the alternative would have been just opposite of what I did with the. Okay. So instead of doing that, let me do this. Can I? Okay, good. If 0. Then make this else. Okay, and this one is and if, right? Now I'm going to write this one. So when I do the restore, my use will be. Okay, I think I remember what I did, yeah. My use will be use B, right? Use B will be used. I have access to use because of the protected base class members. Then from 0 to use B, I assign all the values from B to I. Okay, and let's make this one. No, 0. Okay. So this will not compile, but this part will compile. And this is as simple as this. Okay, just I did the opposite of this this backup thing. Okay, just the opposite of the backup thing. I get the use one, changed the use one, and I did this assignment from 0 to use B. I copied from B to I. This one was copying from A to B. Now I am copying B to A. Okay. But I like this code better. I don't remember if I wrote this or right, because this one uses the public interface. Because when you use the public interface of the base class, you cannot modify the use value, right? Use is private. Use is private. There is no setter for the use. There shouldn't be a setter for the use, right? There should be a setter for use be used. Sorry, there should be a getter for use, but there is no setter for use. So how am I gonna modify the use value? So I guess that's why we did this. We just empty array and put element one by one. So this add element is modifying the use value one by one automatically, and that's going to be it. Okay. Good. That's it. So, but I like this one better. Let's make this one. It works that way. Copy there, backup there. Okay, we are all done. Are there any other functions that I didn't look at yet? No. And we have already looked at the main function, which calls the test pfRAD backup, and pfRAD backup makes a pfRAD object. And it takes a number of integers or doubles from the keyboard, and it adds them one by one, and then it prints them out on the screen. Yeah, and then it prints the get number used. Okay. What is this? So this. Oh, okay. These are the numbers from the keyboard, and it prints them on the screen, and it takes a backup. After immediately taking the backup, just empties the array. Say that my use value is 0, and get number used is 0. Okay, I don't have anything. Then I restore it, and I see that everything is restored. Okay. Any questions? Try to write this class hierarchy yourself, starting from the beginning. Okay. You will see that there are a number of places. This is not confusing, but syntax sometimes makes it confusing a little bit. But if you write 2 or 3 classes like this, your confusion will go away, and you will be fine. Okay. Again, 2 things. It is important to know why we are using inheritance. That's very important. That's the reason why we are using inheritance. But that's not enough. Okay. That's a requirement, but that's not enough. You need to know how you use the inheritance for all the cases, like in case where you need deep copying and etc. With C++ or Java or C#. That's the other thing. If you have both of these things, why we are doing this and how we are doing this with specific language, then you should be fine. You should be fine. Okay, let me ask you a question here. Okay, let's say instead of this hierarchy is nice. This hierarchy is nice. I like that. As always, I always change the things that I like to make them even better. I am going to do. What is the meaning of backup? What is the meaning of backup? The meaning of backup is the meaning of backup is keeping a copy of my pfRAD somewhere, right? Keeping a copy of pfRAD somewhere. So why don't I, instead of doing this, why don't I, can anybody tell me what am I going to write here? Something very simple, what?
A pfRAD object.
Yeah, exactly. Why don't I do pfRAD, just one pfRAD object, and its name will be B. Okay, I will keep this PFRAD as my backup object, and whenever it says backup, I will keep a copy of this object in B. Whenever it says restore, I will get my copy from this B. That's what I'm going to do. Okay, so look at this one. This is very interesting. There is an inheritance hierarchy. Also, there is this composition stuff going on here, right? So PFRAD is both. PFRAD backup is both a PFRAD. Is a relationship there. Also, there is composition there too. So this can both happen. And in this case, it's going to be very useful. The nice thing is, my interface will not change at all, right? My interface will not change at all. It will be exactly the same. Let's try to implement this ourselves. I don't know how, I don't know why I am doing this, but it seemed like a nice idea. Let me copy. Can I do? Yeah. Let's go to my employee H. Where is this? Yeah, well, okay, this is different. 14 and here, and let me copy this PFRAD backup CPP and PFRAD backup H and copy them here. Well, they are automatically called copia and copia. I will keep using those names. Okay, let me open them, both of them. Okay, so this is backup, copy and copy, and I am including this PFRAD, and let's change this. Tell me what I am going to write here. I will say I have a PFRAD object as my backup. That's one thing. Okay, that's it. Question: do I need a big tree for this class? Anybody from the audience? You guys stop. Don't tell me anything. Anybody from the online audience? Are you guys there? Because you are not listening, you are costing me like Turkish liras per 10 minutes or something like that.
We hear you, sir.
Okay, tell me something then. Do I need big free for this my new class? Previously, yeah, I needed it. Now do I need it? Because my private data is like this. It's a simple yes or no, but you guys know that when you say yes or no, I will say why. Yeah. Somebody talking?
Yes, I think it's no, sir.
It's no. Why?
Because we already defined a PFRAD object in the private.
Yeah, well, yeah. Member-wise copy will work fine, right? Okay. When I make a copy of this, my new PFRAD backup objects, member-wise copy will be performed, and member-wise copy on this PFRAD will work fine, because I have already overloaded the assignment operator, copy constructor, and etc. Okay, so what does the assignment operator do by default? It calls the assignment operators of all the data members it has, right? That's why it is dangerous to do the member-wise copy between two pointers, because assignment of a pointer to another pointer, it just copies the pointer, that's it, not deep copy. But assignment of a PFRAD to some other PFRAD, will be handled nicely, so no problems. So I am going to get rid of these two. I don't need them, and I don't need this one, and this one is okay because I need that one. What else? Yeah, well, I will put this nice line that says, okay, default copy constructor, destructor, and assignment operator are okay. Okay, I did that. I didn't put them because I forget them. I didn't put them, I know what I am doing. These are all okay. Okay, so I got rid of all of them, and so class became much simpler. Let's go to the implementation. Let's implement this. Okay, this one is fine. This one is, well, no, it's not. Well, okay, good. So what am I gonna do now? I will call the base classes default constructor, okay, and I can say I can say this. What am I gonna do? Say, tell me. Use B is not B there, right? Get rid of it. Get rid of this. Comma. What? What was my B? Hint for you. B. Either this or just get capacity. That's it. Okay. What am I doing? I am initializing another object, which is supposed to be the backup of my PFRAD. Okay. So what is the capacity of that one? This capacity is my current capacity. My current capacity is PFRAD. Oh, so the capacity will be there. So why did I say that B parentheses is okay? Because 50 is my default capacity. That's why it was okay. So either of them is fine. Let's look at this one. This one again, this one will be gone. And this one will be gone. You know what? I like this one better. Why? B0. Because if I say B get capacity, it will keep 50 doubles somewhere in an unused situation. Well, why should I waste my memory if I don't take the backup now? Okay? I'm just saying that just keep a PFRAD object somewhere. Okay? Don't waste any space now. When I take the backup, I will make the new space. That will be okay. Okay? So that's what I did. Now let's look at this place. PF get capacity. Okay? Capacity value is there. How about my B? What am I gonna do with this B?
Get capacity.
What?
Get capacity.
Or 0. Both of them are okay, but 0 is much better because I know that at the beginning of this class creation, my backup space will not be used until I say backup, right? So I am not going to waste any space for now. When I take the backup, it will be fine. Okay? Okay, this will be clearer when I implement the backup function. Let's get rid of this copy constructor. We like it, but for now we don't have it. We don't need it. Let's take the backup. How am I gonna take the backup? How am I gonna get the backup? Backup is going to modify that B object. Let's do this assignment. I have implemented the assignment. The assignment B gets the value of what? What should I do? B gets the value of How am I going to implement this? B gets the value of my base classes stuff. So what? Okay, does this work?
I don't think so.
Why not?
Because this refers to the PFAD back object.
This is a pointer to a PFRAD backup object, and the reference this returns a PFRAD backup object. This is an assignment for PFRAD object, right? But there's an easy relationship. Why shouldn't this work? Would it work? Definitely it will compile, I'll tell you. Would it work? Answer is yes, it will work. Because I am a PFRAD backup object, I am also a PFRAD object. There's an easy relationship between them, okay? This assignment needs a PFRAD reference, and I am sending a PFRAD reference. This is fine, and it will work. Okay, if you remember the assignment of the PFRAD, what is the type of B? It is PFRAD, right? So this assignment
Yes.
so the assignment is, okay, PFRAD assignment, and this will work. Okay? Okay, that will be fine. Let's go to this restore stuff. By the way, let me get rid of this assignment and destructor. I don't implement any destructors. The base class of destructor will be automatically called. Let's get rid of this one. So what are we going to do now? Does this work? Yeah, this is a very good question. Does this work? Why not? What is the difference between line 28 and line 36?
We need to make this empty first.
Well, if I make this copy, why should I make any difference? Why should it make any difference? Because I am making this assignment, and assignment will take care of everything. Tell me why this, while 28 is, oh, I am way out of my time, but okay, let's stop here. You think about this. Okay, I'll tell you this. Line 28 works. Line 36 doesn't work, doesn't compile at all. Okay. Tell me why this is happening when we come back in 15 minutes. Let's meet here 10:40. Okay, 15 minutes. Saydam maske yok mu ya? Sizin bu yüz ifadelerinizi anlayamıyorum ben. Gözlerden hiçbir şey anlaşılmıyor. Gözler hiçbir halt söylemiyor. Önemli olan ağız değil. Yoklamayı unutturmayın bana bir sonraki ders. En sevdiğim de ders arasında gelip hocam ben yoklamayı kaçırmışım. Ben yoklamayı vermedik ya.
geçenler düşünüyorsun, böyle gruplar mesela. Geçenlerde mezuniyet olmayınca anlattınız. Bu yıl grup diyorum, insanlar diyor ki o ne?
Canım gruba atılan şey mi o? Grup.
Gruba ne yaptı?
Bilmiyorum, çok değişik bir şey var. Print machine'le alakalı olabilir dedim. Sonra baktım hiçbir şeyle alakalı değil. Bağdaştıramadım hiçbir şeyle. Gördün mü?
Olmayan bir şey çalışınca olabilir.
Graf çalıştım.
Graf var. Yani grafı
Bir sürü işte soru hiçbirinde kimse var demiyor graflarda.
graf teori dediğimiz şey graf aynı şey değil mi?
Evet.
Son ders graf teori anlatıldı.
Kimse yazmamış ama graf dedi.
Bizim hoca sonra sözü
Keşke Gizem Hoca olsa. Ben hocaya hiç güvenmiyorum yani. Kimliğini okuyacak. Sorular zor. Konu kolay, soruları zor. Onları bir günde halledersiniz soru çözmek.
program tekrar bakıyorum. Bakın önce konular bakıyorum.
Aynısını konuşuyorsunuz.
Şimdi fonksiyonlardan graf teoriye kadar arada ne olduğunu biliyor musun? O ara herkeste bir boşluk.
Orada yok,
Konudan
kimse de
sonra
yoktu, orada gelmedi.
herkes böyle.
Onlarda çok zor bir şey yok.
Konu olarak hepsi kolay ya.
Ama işte ne olduğunu bilmiyoruz. Ders kaydı yokuşuyor. Bir soru soracak anlamıyoruz.
Soru sıkıntı.
Geçen hafta ben geldim, ders kaydını açmadı mesela. Şey yani Teams'te açmadı veya toplantı buradaydı mı? Ama açtı mı? Yüksek oldu. Ben bakmadım. 10 kişi falan
Son
oldu.
dersi
Bilmiyor ya o ders.
dedim ki hani işte bakın nereye kadar gelmişiz. Kontensiz dinleyince Gizem Hoca anlatıyor.
Gizem Hoca'nın önceki bilmiyorum. İşte Gizem Hoca ne çözdü? Ben de onu izlemedim. Ona katıldım.
Gizem Hoca'dan önceki boktu düşünüyorum. Onu bilmiyorum.
Gizem Hoca Turing Machine çözüyor.
Türk işin çıkar geldi zaten.
Nasıl çıkar ne bileyim. Direkt şeyi ver istemese.
Tanımlamıştı.
Makineyi istiyor.
Nasıl istiyor ya?
Sıkıntı ya.
Çünkü kodun karşısı çok üstüne durur.
Gizem Hoca'ya şey sordum. Sen ne istiyorsun?
Zafer Hoca en son şey işledi. Agile Structure diye bir şey var. Operasyon tanımlıyorsun.
İşte ACG
Agile
zaten grup olup yani grup olmuyor da.
İşte grup, monoid falan.
Onları işledi mi?
Ha işledi.
Bak işlemiş.
Grup, monoid, senin
İşte dedim ya ben burada çalışmadım. Ben bunda ona çalıştım çünkü.
Çıkar mı sınavda? Geçen 2 sene önceki sınavda yok öyle bir şey.
Geçen yıl 25'inden önce işlenmiş ama. Hani bayağı önceden işlenmiş. Ve şeyde de okulun sitesindeki müfredatta da sanırım Turing Machine'den önce. Turing Machine normalde bu dönemde değil. Bizden önceki kısımda yok. Onu neden şimdi anlatmışlar anlamadım.
Vizeyi bayağı geçtik 3 hafta kadar.
Evet o da var. Ama aslında bir önce anlattı bayağı normal. 2000 başından sonra benim falan.
Sokratik falan çözüyor. Değişik bir sınav olacak ya.
Bizde bir şey bilmiyor. Çok var şey ya. Yaşıyorsun da.
ayrıyı da yani zaten
Ama
o
bunun olayı çok zor değil bu arada ya.
ayrı konu da
Ortalama yükselsin.
gerçekten beni bayağı çökecek ya böyle.
Ben geçmeye bakıyorum sadece.
İşte
Ortalama umurumda değil.
şöyle
2 ile
bir şey-
geçsem. Geçeyim yeter ya.
Toplu 90'a kasılınca yani çok zor.
öyle zaten de şöyle düşün. Mesela CC alamadığım DC'ye falan kaldı ama hepsi ortalama düşük olduğu için hepsini aldım.
Kötü oldu.
Biz keşke ikinci sınıf online'a getirebilseydik.
Yok ya yani
Ben de birinci sınıfta kalabilirim.
Matematik yönümüzü mü bence ya?
Size zor.
ama ortalama o kadar yüksek olmaz.
Bizimkiler
Biraz
yüksek
biraz
olmuşlar.
değerli herkes.
Türkçe'de
Onların
biraz
katsayısı
var.
yüksektir.
Aynen öyle
Matematiğin
kitap onlar da var.
katsayısı var.
Oturdum kağıt çok
Yani
yani.
oturup Türkçe'nin club çalışmam.
Aynen öyle var.
İyi geçtik yani. Güzel oldu. Yani Türkçe'nin club var yani.
Ya bunlar mesela en azından bölüm dersi şu an öyle düşünüyorum. Mesela böyle çok yorgun
Elektronikçi arkadaşa vizeyi gösterdim. Birkaçını çözemedim.
benim de elektronik arkadaşım yakın arkadaşım. Ama ona rağmen videoda yapamadım ya. Çok üzüldüm.
Ozan. Senin neydi?
Konuşmadığım hiç şey olmadığı için.
Aynen. Bir sınıf çok sessiz ya kaynaşmada olsa işte konuşmaya
Bir de
falan.
herkesin az çok kendi arkadaşı var ya. Ders bittikten sonra da herkes onlarla çıkıp gidiyor yani.
İşte bir şey de kötü şimdi. 11.30'a kadar ders var. 11.30'dan sonra ders olmasın herkes gidiyor yani. Bugün var da bugün de ayrı kimse girmez herhalde.
Yani tam tersi belki bir şey faydalı bir şeyler söylerler diye bilmeyi düşünüyorum. Geliyor en azından.
Yarın sınav soruları veriyor.
Değerli incelemeyi hak ettim. Biliyor musun? Tekrar işte şunlar önemli. Bir şeyler söylerler diye.
Bunları sor gireceksin. Harbi diyorum. Hocam ne işledik?
Vallahi.
Hocam şeyse baştan sona tekrar edin. Anlattığı üzerinden geçelim de çaktırma
Bak,
da.
grup işledik değil mi?
İşledik grup mu? Senin grup işledi üstüne durdu bayağı.
Bak işlemiş. Beni insanlar korkuttu.
Kim?
Ben dün grup çalıştı da herkes diyor ki grup işledik.
Ama sadece grup değil. İşte onların monoid, semi grup falan onları da işte.
Tamam ben şu an sadece grup biliyorum.
Bak anlat da sen anlatamam.
Semi grup bilmiyorum.
Semi grup sadece associative olan.
Biliyorsun.
Associated.
İsim olarak biliyorum.
İlk
Bir
onları
dakika
biliyorsun.
ben yine bu dersten çalıştığım için Türkçe'ye de çalıştım.
İngilizce çalışamalısın.
Değişme özelliği.
Aynen değişme özelliği. Değişme değil de şey mesela. Parantezinde daha tutar ve
Birleşme.
Tamam.
Baktın mı şey? Dediğime baktın mı? Onu bulamadım ya.
Nasıl bulamadım? Ben de
Hangi söyledim acaba?
Bak, ben anlamadım hiçbir şey. Grup falan dediğin olabilir.
Bugün kesin keser mi? Ne sorsam yarın da olur.
Ben şeyleri ders hakkında yapar diye korktum.
Yes, tamam da galiba.
Her akşam
Çürük
görürüz.
peşinde register falan mı var?
Ne efendim?
Çürük peşinde register falan mı var?
Vallahi hiç bilmiyorum.
Öyle bir şey gördüm.
Register, grupta register diye bir şey yok. Grupta register oluyor.
Grupta öyle bir şey yok.
Aynen grup ne biliyor musun? Matematikte birleş dağılma özelliği falan filan var ya. Onun bir işleme uygulanmışlar.
Ya şöyle
Mesela toplum üzerine
ya
bağlı.
hani şey vardı YKS sınavlarında vardı işte mesela yıldız veriyordu. Yıldız bir işlem diyordu.
Grup ondan. Aynen aynen.
Yani o tarz bir şey işte onlar.
Ne anlamadım.
Mesela hani aynı değil yani YKS'de mesela bir tane diyordu ya ki
Mesela
üç
üçgen
tane şekli aynen.
mesela A üçgen B diyordu. Üçgen bir işlemdir diyordu. O tarz yani.
Yani mesela
Tabii
iki
işlemler
mesela iki üçgen iki eşittir 5. Hani işte o ne yapıyor? İşte atıyorum iki kadının bir eksiğini alan bir işlem demek ya. İşte grup dediğimiz şey de bu yani. Başka
Grup dediğimiz şey bu değil. Grup dediğimiz şey bu işlemin 2-3 tane özelliği var. Onu sağlarsan
Aynen.
grup oluyor.
İşte o özellik olacak.
3-4 tane grup vardı. 3-4 tane özelliği vardı işte.
O olacak. Sonra işte böyle bir tane dediğim gibi kanalite var işte. Onları
Onları da işte.
şey
Senin
yani.
o kod değil, associated şey var.
Rütbe gibi düşünüyorum. Bir cümleden sonra
T ile başka ne vardı? Bir de identity vardı. Identity
basit bir yani. Bir şey yok.
toplamada çarpmada bir var ya.
Ayrı konular
İşlem sonucunda soldaki elemanın dönmeni değiştirmiyor. Yani o identity şey oluyor işte.
Çünkü ben hiçbir şey görmedim. Türk meşin falan da yok orada. Zaten
Yok herhalde. Türkmeşin bilmiyorum. İşte dün gruplara baktım. Bugün
Bir şey anlatıyor da.
Ben de anlamadım ama masum anlatamıyorum. Sadece bir çocuk. Konuş altını söyledim. Grup falan var ya onlar işte.
Allah'ım varmış grup ya. Mutlu oldum. Gerçekten boşa çalıştığımı düşünüyorum.
bu dersten çalışsam yerine
Yetişir.
Çok az konu vardı. Çok az şey vardı ya. Direkt kaç video diyeyim sana? Maksimum 20 video falan vardı o grup kısmıyla alakalı. O da soru çözümleri dahil.
neredeydi hangi
Tam
altı?
bir PDF vardı bir yere. Ben ona baktım da. Bitirdim mi ama yani öyle şeyler görmedim.
Neyi?
Konular çok kolay.
Ama işte
Bize
kimse
çok kolay.
Ayrıca mı? Playlist'te.
PDF'de slide vardı, bir şeyler vardı. PDF vardı. Tüm konular çok tuhaf sorular sor. Gruba atılmış bir şeyler var.
Bir tane o şey, bu işlemlerle ilgili bir tane tablo oluşturdu. Tanıttığım tablo.
Evet. Ve tablo.
Yani tablodan bakarak yapıyorsun.
Geçen sene definition falan da sormuş. Gördün mü? Yeni şeyler yazmış. Graf
O set falanlara baktınız mı? Ben de bilmiyorum.
Şey veriyor, sana küme veriyor. Bir de bunların ortak bir özelliğini veriyor. İşte bölen işareti veriyor. Hangisini bölüyorsan. 3, 4, 6, 12.
kolay o ya. Pas ederken de
Mesela 3, 4'ü 3, 4'ü bölemiyor ya. 3,4 diye bir şey var. 3,6 var. 3,6. Kolay. Kolay. Poşet yazınca çıkmıyor.
graf diye bir şey.
Sağda ufak poşet çıkıyor. Parça değil, orada bir set yazmak.
Ben geçen hafta ders önce 3 hafta falan geldim.
Ben ilk girdim sadece arayışına. Sonra yüklenci
Biraz da onların izlenmiyorsa
Normalde de izlenmiş.
normalde geçen hafta geldim editim iyiydi. Konum güzeldi. Onda anladım. O videomu anladım orada. Onun dışında zor yani. Onlarda hiç izleyemedim. Açtım sonra.
Bu arada geçen hafta gerçekten benim öyle geçti. Sadece bir müsait olmadığı için izlemedim.
Geçen haftadan yeni açamadım galiba.
Öyle mi?
Aynen, yarısını açtı, yarısını benim öyle bir şey oldu. Aynen. Sen bir ders veriyorsun galiba. Bir tanesi
Kağıttan daha sonrasında bana kağıt geliyor. Kağıttan anlatıyor ya çok tuhaf geliyor. Yani şu an ben bile sana sözleri anlatabilirim sana.
Belki bir şey unutmamak.
not alıyordur ya.
Ama hani bayağı bir sayfa sayfa not geçiriyor ya. Sayfa sayfa not geçiriyor ya. Mesela o soru soracak. Yani o mantıklı. Neden değerleri kullanmak mantıklı? Ben sana anlatırken o kadar güzel.
Sadece çok bağırıyor. Ben dinleyemiyorum. Çok aşırı Yüz yüze görmedim de böyle online girdim. Bir kere girdim zaten.
Şu an konuştuğun her şeyi kayıt edebiliyorsun. Bir de çok geçe kaldı bu sınav. Şurada herkesin üzerine gitti ya.
Ama onların daha çok sınavı var bize göre.
Elektroniklerin daha çok dersi var aslında.
4 tane sınav var zaten.
Ya insanlar çok zorluyor. Nasıl yani? Sadece bu kadar dersiz. Kabul etmek istemiyorum.
Bölüm bilenler bana şey iyi bu sene biraz daha kolay.
Cidden mi?
Evet.
Az dersiniz var değil mi?
Az dersimiz var mı? Mesela elektronik dersi girerse bilinçli gibi bir şey. Hem devre tasarım var hem elektronik var.
Şey gibi. Bu hafta da laboratuvar. Önümüzdeki hafta olmayacak.
Galiba.
Ha,
Olmasın da var.
Okay. So that question, back to the question. Am I connected? Not this one, but yeah. GTU stuff works. Okay. Anybody has any ideas about this? Why 36 doesn't work? Yeah?
The reference of this is a constant.
Which one is constant?
The reference this is a constant.
Yeah, that's one of the reasons. Yes, that's true. Exactly. But if it wasn't a constant, if it wasn't a constant, it still doesn't work. Okay. The reason is, okay, is a relationship is a one-directional relationship. Okay. We say that PFRAD backup is a PFRAD, but the opposite is not true. Okay. You can say that PFRAD is PFRAD backup. Okay. This assignment is trying to do exactly the opposite. It's just trying to assign a base class object to a derived class object, right? Because this left side is a derived class object, right side is a base class object. Doesn't work that way. Is a relationship is a one-directional relationship. Okay. So we have to do something else. Do you have any ideas? Maybe I can do this, right? Maybe I just can get rid of these lines to Control Shift dot what, like this. No, I forgot what was the Control M. Edit. On command is, yeah, Control comma. Yeah, okay. Control comma. Yeah, okay. So I just empty my array, and from 0 to get used, just add element BI. Yeah, BI will work because B is my base stuff. This will work. Yeah, okay. This will work. Can I write this even better? Can I write this in a short form? Because I have my, how about this? How about this? Make a temporary object. Yeah, PF array D, a temp or backup, okay? A temporary object, and this temporary object will get, would this work? No. Why? Because again, there is a relationship just the opposite. If I do this temporary and B, I have already that one. Well, I mean, you figure this out. Let's try to write this in a like this one, like 1 or 2 lines of code without running any loops. But this loop will run anyway, but you don't have to run it. Let somebody else run this loop. Okay, run this loop. This will not, yeah, this will just make a copy. How do I put all that stuff inside my, yeah, I mean, for now I cannot think anything better than this. Good. Okay. Any questions? Any questions? So this turned out to be very simple class. I mean, class is not simple. I mean, lots of things going on, but in terms of implementation, it is very simple. That's the beauty of object-oriented programming. By writing this kind of simple code, understandable code, okay, you end up writing complicated software. Okay, I have written only just this line, and if I think I can do better than this, okay, without running any loops, and rest of them is just simple stuff, and I am reusing the code that I have. I am reusing this code, my base class, as both my base class as a composition class, both of them, to write a more complicated class like the backup class, and everything should work fine. And I can tell you something else. I can do even better than that. How about this one? How about this one? Yeah. And you complete this one yourself. Whenever I say backup, it will push one PFRAD object to this vector. Okay? So I can take multiple backups. Take a backup and another backup and another backup. Okay? When you do the restore, I can pick any of them and do the restoration. Okay? Do the restore with an integer. So you say that restore me the 5th backup or the 4th backup or the 3rd backup. Okay? So implementing this should not be a problem. What are you going to do? Oh, by the way, this restore is not the restore of the base class, because this one takes a, oh well, okay, because yeah, this is fine. I thought that the base class is a restore. This is my first restore. So every time I take a backup, I push one PFRAD to this vector, and when I do the restore, I just take one value and restore it from that value. And this is a very complex capable class, but the line of code that I write is very small. Line of code that I write is very small. It will not be any larger than the number of lines. It will not be any larger than this much. Okay. So backup will be, so tell me what should I do with the backup? Backup should be b dot push back. Right? That's it. Okay. B dot push back this. Just back up. When you do the restoration will take an integer I, and it will be empty array, it will be B. Okay, let me make this J. J. This one will be J and I. How about this one? B J dot get used. Right. So I have already implemented it. The point I am trying to make is, again, if you build software right, okay, if you think in advance, if you make these kind of refactoring work, what is refactoring? Write some code first, test it, and see if it works. And after that, you get ideas for improvement in terms of efficiency and in terms of writing better code, and rewrite your code again. Okay, and object-oriented programming rules will help you to achieve this kind of very little code, but meaningful code, efficient code, and reusable code, most importantly. Okay, that's what we are doing here. Okay, any questions? Okay, if there are no questions, then I will go back to my slides. And again, exercise. Write this PFRAD and PFRAD backup, the original ones, yourself, without looking at the book's code. Then do these modifications. Do the one that takes the infinite number of backups. And don't forget about this, making this PFRAD class really dynamic, truly dynamic. Because I have this capacity now for this one. I am not reallocating my space if the space is not enough. Remember that one? And do that one too. That will be good exercise for you. Okay, so we talked about this functions not inherited. We have we talked about destructor, constructor, and assignment operator. These are not inherited in the usual way they are inherited. You don't have to use them, but if you use them, you should know what you are doing. That's what we did in both cases. Okay, we have implemented for this hierarchy. Definitely we need the big three for this one and this one. For this one, big three is needed for this, but not for this one. Okay, assignment operators and copy constructors. Okay, they are not inherited as usual, and typically they must be used, and typically if the base class overloads them, defines them, you need to refine them too. And there is one nice example here. Okay, if let's say I have a base class and derived class, I am writing the assignment operator for the derived class because it is needed. So usually you start with this. You will say that I am going to call the base class's assignment operator with my right side. Even though this is the base class assignment operator, sending a right side object, which is derived, is okay because there is an is-a relationship. So the direction of the is-a relationship is this way. Okay. So that's what we are saying here. It says, call the assignment operator from base class. Okay, this takes care of all inherited member variables. And then we will continue with the rest of the class, not inherited ones, the newly introduced variables. Okay. And copy constructor again. If you are writing a copy constructor for the derived class, then you would call the base class's copy constructor in the initialization section, because this is a constructor, right? In the initialization section, I would call the base class's constructor and continue that way. Okay? Good. What else? And the destructors are, again, we don't call destructors at all. I mean, there is no place in C++ that will tell you that call the destructor yourself. Okay, destructors are automatically called. You just write your destructors and you don't call them, okay? Compiler calls them automatically. So what are you going to do? Here's a small class hierarchy. There is a base class and there is a derived class. Okay, very simple class. Doesn't have any data. Base class, there is a constructor. It just prints out this message, be base class constructor, and the destructor prints out this be destructor. Okay, and for this part, this is destructor derived. Sorry, this is the derived class from base class B, and I do this again, print this message and print this message. Don't forget about this one. See, I am calling the base classes no parameter constructor. Doesn't matter if you call this or not, this will be called automatically. Okay, it will be called automatically because what was the rule again? If you don't call the base classes constructor in your derived class constructor, a no parameter constructor will be called automatically, but I am doing it myself here. So what would happen if I do this? In my main function, I make a base class object B and I make a derived class object D. Of course, this base class object B, okay, base class object B, when it is created, the constructor will be called. When I hit this line, the destructor will be called, right? That's what's going to happen. The interesting thing happens here. This derived class object, okay, since when the constructor is called for the derived class object, I am calling the base class as constructor too. So for this object, I will see two printout cout statements on the screen. One will be for the base class, one will be for the derived class. Sorry, one will be for the base class and one will be for the derived class. When this object dies, two destructors will be called. Okay, one for the base class, one for the derived class. So this is what I am going to get. Okay, this line. When this line is executed, this will be printed because I am calling the constructor of the base class. That's it. Okay. When I execute this line, this will be printed. But when I execute this line, okay, since this is the derived class, this is my derived class. Derived class constructor says that I am going to call the base class constructor. Base class constructor says that this is the base class constructor. It prints this one on the screen. And then after that, derived classes constructor will print on the screen. That's what I am going to get now. Okay, so I will get one base class constructor printout and one derived class constructor printout. Okay, good. So these two come from this line, and this line will come from this line. When these two objects die, okay, first this one will die because it is at the top of the stack. It will be popped and it will be killed, okay. When this one dies, okay, this destructor will be called, but automatically this destructor will be called too, okay. Which one will be called first? Okay, the destructor of the derived class will be called first. So the destructor will be called first, then the B destructor, base class destructor will be called. Okay, so here this is happens here, and then another one here. And when this object B dies, the destructor of the base class will be called again. It's just, I mean, if you are confused, just use this rule, okay? So the destructor calling order is just the opposite of the constructor calling order. So the last time this destructor, so the last constructor, the first destructor, then this, then that. Okay, this is very similar to composition constructor destructor calling order. Okay, very similar to that. If you have an object in your class through composition, before your class starts working, you call its constructor, right? So before the main class's constructor works, the constructor of the composed objects class will be called. Okay, so do this experiment yourself and make it more interesting. Put some objects in it, day of year objects in this one, or make another class C, okay, C, and make class C part of this class B and class D through composition, and see when the constructors and destructors are called. Good. Any questions? These are important because if you don't know the calling order of these constructors and the destructors, sometimes you run into issues. I mean, did I deallocate my memory before the destructor of my base class is called, etc. So that will make you think a little. But if you know these rules, you should be fine. Okay, so destructor calling order. If you have this A, B, and C, okay. If you have these classes, if I make an object of C will look like this. Okay, C is one large object. It contains an B object in it, and it contains an A object in it. And C is considered, is a relationship. C is a B object, and C is an A object. C can behave like an A object or B object or C object, right? That we know because of the is a relationship. So while you are constructing a C object, what would you do? Of course, you need to construct an A first, right? You need to construct an A first, then B next, then C. Okay, that's the order of construction. When you are destroying this object C, you need to destroy this green part first, then the red part, then the black part. Okay, that's the. You cannot change these orders. It is not up to you. I'm just trying to explain why they had chosen it that way. Okay. So it is best the best way to learn this, again, writing this kind of code and making and doing exercises. Okay. Read this statement very carefully. This is not exactly true. Okay. When I say I have a new C object, C, O, okay, this one says that, okay. Let's look at the destructor part. First the destructor of C, then B, then A, right? So C, destructor B, and destructor A. And this one says that opposite of how the constructors are called, then it should be C, B, and A. That's what it says, right? First, when I do this, first the constructor of A, then B, then C. Then when the object dies, the destructor of C, then B, then A. That's what it says. This is not exactly true, because when I do this, the constructor of C is called first, actually. But C, as soon as I call this constructor calls the constructor of B, which in turn calls the constructor of A. So the first one that finishes execution is constructor of A. Okay, so the first printout statement will come from constructor of A, then B, then C. Okay, so the constructor of C will finish last. Even though it started first, it will finish last, right? So this statement is exactly not true because the calling order is always the derived class and the base class and the base class, but the topmost class, the class at the top, the constructor for that one has to finish the first. Okay, good. So then let's look at this is a versus has a relationship again. Okay, this is a very important concept in object-oriented programming. And when you are writing classes, designing a single class is important, of course. Follow all the object-oriented rules when you are designing the classes, object-oriented classes. That's important. Also, the relationship between the classes are important too. You don't design your classes in isolation. You have to think about other classes when you are designing classes. So you have to make a decision. Are these two classes related to, has a relationship, or is a relationship, or there are some other kind of relationships? Okay, and try to figure this out first. Okay, and I am not saying that is better than has a, or has a is better than is a. There is always a trade-off. There are always some advantages and disadvantages depending on the cases. Think about this before you make your decision. It is okay to write some code, make it run, and see what is running good and what is not running good, or what kind of code looks good and what kind of code doesn't look good. Okay, in terms of efficiency and in terms of number of lines of code. And it is okay to write a second iteration for your software. That's called maybe refactoring, writing it again. Okay, that's called agile coding. Write some code that works somehow and repeat this process until you are happy with your final results. Okay, so usually when you are doing this, you will see cases where is appropriate or has is appropriate. Make your decision, write your code, run it, and see try to figure out what kind of alternatives would have been better. Okay, we are not in this class, okay, CSE 241. We are not teaching you how to design very large software systems using object-oriented programming. I am just trying to teach you what an object-oriented programming language does, okay? The basics of it. You will have some courses in your third year or fourth year about designing such software systems. In that case, they will give you lots of rules about designing object-oriented programming systems. There will be some rules. For example, let me try to get them. And it depends. It depends who you are getting these rules from. Basic OPL system rules, or maybe I shouldn't say object-oriented programming. Okay, object-oriented system rules. Maybe I should say object-oriented. I couldn't find them. Okay, yeah, good. Yeah. See, let's see one of them that will, okay. Srp principle. It says that a class should have only a single responsibility. Don't make soup classes. A class does this and this and this, and you add many functions to a class, okay, 15 functions, and that class is trying to achieve more than one thing. Don't do this, okay? For a single purpose, write a single class. Single responsibility principle, okay? Okay, and object-oriented programming requires, okay, this is open-close principle. Software entity should be open for extension but closed for modification. Don't develop code thinking that in the future I am going to modify this one to add this functionality. Don't do that, okay? Inheritance is a very good example for this one. You write your base class, later you extend it. You add more classes to it. Don't modify your base class, right? That's what it says. Okay, some of them are kind of difficult to difficult to understand in a few seconds. Okay, this dependency inversion, etc. So if you look up, there are many. These are called solid principles. Why it is solid? Because SOLID. Okay, just to remember them. And I think at the end of the semester, I will invite somebody from industry, Mustafa. He is one of our graduates. He will talk about these solid principles, okay? why they are useful, why we are doing this. So in this again class, we don't talk about these kind of object-oriented design rules. All I am teaching is object-oriented programming language. Okay. So it's like teaching you calculus, not without telling you anything about where you are going to use the calculus. I can give you only examples, but if I go into this kind of stuff, I cannot teach you both of them. It would be very difficult for me. All I can do is I can talk about them. Okay, so is and has a relationship. You need to know the differences between them so that you can understand those kind of rules. Okay, so we talked about this, and it is always important. It is always important to know what composition. Remember this holiday and day of year, there is a composition relationship between them. Remember your homework. You have seg, peg, solitaire. Okay, peg, solitaire, and cell is both an inner class and the composition, true composition. You use them. Okay. And I made those decisions myself actually when I'm designing your homeworks. Okay, usually giving homeworks that makes you make these kind of decisions, design decisions, is difficult. It is very difficult to grade those kind of homeworks. But if you think about them, why we are doing this, why would it be better if I do it the other way? That would teach you lots of stuff for you. Okay, let's talk about this most popular question. What happens if I put private here or protected here instead of public? Okay. What did I say at the beginning of this chapter? Don't do that. It is allowable. It has some meaning, but we are not going to use it. That's the meaning of it. Okay. New inheritance forms, but both are really used. If you write protected here, okay, the public member in base class become protected in your derived class. So the public functions and public data of your base class becomes your protected data and function members. Okay? That's what happens. If you put private, your public, okay, all of the members in the base class become your private data and function members. Obviously, this is not an is-a relationship anymore, because if the public functions of my base class becomes private, my customers cannot use them, right? So this is not an is-a relationship anymore. I cannot, if you think about the PFRAD backup class, if I use the private derivation here, get number, get used, get capacity becomes private functions. If they are private, my customers cannot use them. So I cannot behave like a PFRAD object. So this is not an is-a relationship anymore. And other than that, we don't like these kind of inheritance methods. Is-a relationship is something that we like. So that's why we don't use them at all. But they are available. Okay? Good. So don't ask any questions about this. Just know it. Never use it. Never use it. I mean, you might think that what is wrong with using them? I mean, yeah, well, if you know the behavior, that's true. But if you start with something that is not an is-a relationship or composition, that's not an extensible code, okay? Extendable code. That will be some weird code that cannot be extended later. You will end up modifying it, and that will be against one of the solid rules. Okay, another topic is multiple inheritance. In C++, multiple inheritance is allowed and it is used. And your book says that it is dangerous, it is too complicated, don't do that, and etc. I don't agree with that. Okay, whenever the time comes, use multiple inheritance. For example, this is very nice here, right? Okay. I I have a person class and I have an employee class. Any person should have a name, social security number, and address. And any employee should have, okay, a salary and start date, right? Why shouldn't I write a nice hourly employee class out of these two? This one will take care of the person details, this one will take care of the employee details, and I am done here, right? I inherit all of them. So this is fine. This is nice. If you look at this picture, the problem becomes this. The problem is this. Okay, there is a base class person. There is a student derived class. There is an employee class, and nice I did the student employee. The thing is this. I am inheriting this person in two paths. One is from this path. The other one is from this path. Okay, so person becomes 2 times my base class. So I have inherited this name 2 times. I will keep 2 names in my class now. That's the problem. So these kind of problems makes the C++ compilers very, very complicated. Java just avoids this problem. Java says that there is no multiple inheritance. If you are going to do the inheritance, it's going to be only a single inheritance. Just one parent, that's it. Okay? It just eliminates it. C++ doesn't say so. It says multiple inheritance is allowed. But if you have these kind of problems, there are some solutions for it. And for the other parts, you have to be careful. Okay? For the other parts, you have to be careful. And I think I gave you, yeah, this is the picture. If you declare a student employee object in your memory, okay, you have 2 parts. You have student part and the employee part. Inside student, there is a person and there is another person, okay? So do I keep my name in 2 different places? It looks weird, right? It's just waste of memory. I have a single name and I should keep it somewhere. There are some solutions for it. There is a mechanism called virtual inheritance. The keyword virtual used in there. But we will not go into that kind of detail. Although I like to talk about it much. Usually the textbooks, they don't go into this kind of detail because Java has a better solution for this. Even though Java doesn't use multiple inheritance, it has for them a better solution for this kind of problems. It says multiple inheritance is not allowed, but we can use multiple interfaces for that, and we are going to talk about it. And by the way, this is how you do it. Class, my class name, public, base 1, base 2. You separate them with commas. Okay? There are some ambiguous situations, but we will ignore them for now. And I guess that will be the end of the chapter, of this chapter. And tomorrow I will start talking about polymorphism, which is based on inheritance. Again, we will be talking about the inheritance. And I don't like much of the code that is given by the book, so I am going to write my own code or something like that. But at the end, we will come back to the book's slides and we will talk about what the book says about polymorphism. Okay? Good. Any questions? Any questions? Okay, if there are no questions, then I will stop here. I will see you tomorrow. Where is my attendance? Attendance?